Yes, class. So yesterday we had stopped at AC dynamo. Now average value of AC for full cycle and half cycle, it can come in your exam. So let us discuss that first. I is equal to I naught sine omega t. I is the value of current. What is I naught? We write this as I naught sine omega t. Yesterday also I told you that current depends upon the angular frequency and time. Okay. So this way we call this I naught. This is the peak value, or you can say this is the amplitude, or this is the maximum value. So current, it's dq over dt. This is fixed. So from here, if I ask you to calculate dt, it will be I dt, integrating it from 0 to t. Why? Because for full cycle, this is. Now when you have to integrate I, what is the value of I? I is equal to I naught sine omega t dt. So integrating it from 0 to t. Correct. Now you just have to apply the derivation. Yesterday also I told you, okay, when you are integrating or differentiating, integral of sine omega t. When you are integrating sine omega t, you will get minus cos omega t by omega. Always remember this for integrals. So from 0 to capital T. So this is minus I naught. What we can take omega also outside. Or let me write it as 2 pi by t only. No, omega is equal to 2 pi by t. So I'm taking it up. Now what are we left with? Minus cos omega t. Okay, minus sign also I have taken. No? So what are we left with? Only cos omega t. So cos omega, first put the upper limit, that is capital T, minus cos omega, put the lower limit, 0. So minus I naught t by 2 pi cos omega t. This is cos 2 pi by t into t. Why? Because omega's value I am putting. Look, this is the value of omega. This I am putting it here. Minus cos 0 degree is 1. T will be cancelled. So this gives minus I naught t by 2 pi. Cos 2 pi is 1. This is minus 1. So this will be 0. This is 0 directly. Right, this is cos omega capital T. So cos 2 pi is equal to 0. So your current is also 0. Your EMF is also 0 for a full cycle. Look here, I is dq, you are asking this part. Look, dq is equal to I dt. Then value of current I have put I naught sine omega t. So once you will be calculating this I naught sine omega t1, yes, this will be from 0 to t. Correct. So this is also 0. Write it down, then we'll discuss if this is half cycle, what will be the variation. T class, if this is over half cycle, what do you think would be the change? If the same thing, average cycle we are calculating, but I told you this is for full. If I'm saying this is for half cycle, what will be the difference? Any idea? See, for half cycle, I'll write it as T by 2. All right, I'll write this as T by 2. So this will be T by 2. Here also 2 will be there. 2 will be cancelled. Now the answer's difference will start from here. This won't be 0 this time. Look here, class. If cos pi, this 2 was earlier there. Now this 2 is getting cancelled. So what we'll be left with? Only cos pi. Cos pi is 180 degree, which is minus 1. Okay. So which is minus I naught t by 2 pi into minus 2. So minus 2 minus minus sign will be cancelled. So I naught t by pi. This is equal to I naught t by pi. So look, average will be what? Charge divided by time. Time is t by 2. So what is the value of charge that we have obtained? I naught t by pi into t by 2, which is equal to 2 I naught by pi. All right, so I average, when you calculate t by pi, no, that is 2 by pi, that is 2 divided by 3.14. It will be 0.637 times the current. So 0.63 times the current. What is the current? I naught. Same thing, same derivation, you can do it for E average also. 0.637 into E naught. This same thing, same thing. So these derivation come in your exam. Write this down quickly. First part you will be able to write it very well. Just copy it down. T by 2 you have to change. Okay, class. Now we have a concept of RMS current, which is also called effective current, virtual current, but usually you will be using the term RMS current. See, RMS. R stands for root, M stands for mean, and S stands for square. But we know it's RMS, but we'll first square it. I square we'll put. Okay. Second, we'll calculate the mean then. Second step. Second step will be this. So how do you calculate the mean? You take the average value of current divided by the total time. 0 to t. And then lastly, you take the root. Lastly, you put the root. Now you just have to solve this in order to get the value. See, I'll put it in here. First, let me just solve this I square dt. Let me just solve this. I am just solving this separately, 0 to t, because this is easier to solve. If I'll put it under the root, no, you'll be able to, it will be difficult for you to identify. So this is I naught square. This is sine square omega t dt, integrating it from 0 to t. Again, coming back to the integration, we have already seen how to deal with these. I naught square, take it common. Sine square omega t is differentiated as 1 minus cos 2 omega t divided by 2. This you have to learn, class. All right, this you have to learn. Students who have mathematics, they'll be studying it in detail. You people have to remember this. So I naught square by 2, this 2 I'm putting it here. Now, 1 minus cos 2 omega t is there. This is yet to be integrated, right? This is left to be integrated. Sine square omega t, I can write it. This is an identity. Integration part is still left. No, this is not integration. When I'll integrate this, dt will be multiplied here. So I'll get t minus. This is written as sine 2 omega t divided by 2 omega. The way we normally write it, cos omega t, how do we write it? Cos sine omega by omega. So here 2 is there. So sine 2 omega t by 2 omega. All right, so you are integrating it from 0 to t. Whichever step you're not understanding, ask me, class. Some things you have to remember here in this lesson, I understand. But the derivation calculation part you can ask. So this is capital T, upper limit. Let's take 1 by 2 omega also common. So we are left with sine 2 omega t to substitute in the value from 0 to t. That's it. So I naught square by 2 t minus 1 by 2 omega. This is written as sine 4 pi by capital T. Right? Why? Why 4 pi? Because omega is 2 pi. 2 multiplied to 2 pi will give 4 pi into t. Then you have the limits from 0 to t. These derivations can be asked to you in the exam, class. This is not something extra that we are doing it. Okay. So please revise this. So t minus, if we have 1 by 2 omega, first we'll put the upper limit. That becomes sine 4 pi minus second one is sine 0. See, this is 0 itself. Sine 4 pi is 0. So 0 minus 0 will give 0. And 0 multiplied to this term, entire bracket will be 0. So what we are left with? Integration of I square dt from 0 to capital T is just I naught square capital T by 2. Now, what all things were left? Putting it. See, we have solved this. Now, let's put it in here. So, IRMS is equal to, this can be written as I naught square T. Sorry, this is T by 2. And this T was already there, remember? And a root was there. So, 2 gets cancelled. I naught by root 2. This is a very, very, very important relation, class. Very important relation. Throughout it will be there. IRMS is equal to peak value. That is I naught amplitude divided by root 2. Similarly, same. ERMS is equal to E naught by root 2. Both these derivations are extremely important, class. Extremely. How will you use this? How will you see? See, let me show you a question. E is equal to 140 sine omega t. This is an equation given to you. E is equal to 140 sine omega t. Can you see this equation? E is equal to E naught sine omega t. Can you tell me what is the peak value of voltage? The first part is asking peak value of voltage. Yes, class. What is the peak value of voltage? What do you think is the answer? Both the equations I have written. What value can you relate with? See, E naught is given. Look here. This is related to E naught, where 140 is there, where E naught had to be there is 140. Similarly, where omega is there, you have 300. So from this, you can at least say for the first part that peak value E naught is equal to 140 volt. Fine. RMS, we can calculate it later. From this, at least two things you can say. Now for the second part, we have just done a derivation. E naught by root 2 is equal to E RMS. So what is ERMS? ERMS is 140 divided by root 2. All right, which you can further write it as 140 divided by 1.41, which is almost equal to 100 volts. Last part is frequency. If you don't know frequency, at least you know omega is equal to 300. And what is omega equal to? Omega is equal to 2 pi. So 2 pi nu is equal to 300. This frequency is missing. Frequency will be 300 by 2 pi, which is equal to 150 by pi hertz. Tell me, the concept of RMS is now clear or not? Deborah, clear? Aliza, clear to you?
Yes, ma'am.
Okay. Write it down. Write down this derivation. These derivations can be asked in the exam. Okay, yes, class. The next topic, that is phasors. See, in alternating current, we'll be using phasors a lot. Phasors are what? Phasors are basically, they are used to represent that vectors, two vectors mainly. We'll be talking about current and voltage. So we have different types of circuits. You have a circuit which will be having only a resistor. You will see a circuit that will having only an inductor. Fine. You will see a circuit that will have only a capacitor. Sometimes you will see capacitor resistor, their combination is made. Sometimes you will see that inductor and resistors combination is being made. So different types of devices you have. So phasor is what? Phasor is basically a rotating vector that represents a sinusoidally varying quantity. Because we many a times want to compare. So for the comparison purposes, we have these phasors. All right, mainly for the comparison purposes, we have it. All right, so what are phasor diagrams? A diagram that represents an alternating current and voltage of same frequency as rotating vectors. How? Look, suppose this is a phasor. Now, if I tell you this is current, let's say I naught, this is current, peak value of current, and this is E naught. Between them, the angle is made, that is phi. So you can at least predict a thing that I naught is greater than E naught by magnitude by angle phi. So what are these? And suppose I tell you that after a while, E naught is here. So what happened to E naught? E naught rotated. From here, E naught rotated. E naught is suppose rotating like this. So all the vectors are rotating and their respective positions are being shown. Understood? Their respective positions are shown like this. So that is what is meant by a phasor. I'll start with this. First, write it down. Then I'll start with the resistor one. So you will get an idea how phasors are exactly. Write this down first. Now pay attention here, class. You just have a resistor circuit. All right, AC circuit containing only resistor like this. So E is equal to E naught sine omega t. Now, one thing you know, voltage is what here? Voltage is the EMF, that is E naught sine omega t here. So what we can do? We know V is equal to IR, correct? It means EMF is equal to IR using which law? Ohm's law. This we have used it so many times. By now, you must be familiar with it. And what is the value of E? E is equal to E naught sine omega t is equal to IR. Now, current is E naught divided by R, that is sine omega t. Fine. I is equal to E naught sine omega t. What is I? I is equal to I naught sine omega t. Where your I naught? You can look here. I naught is equal to E naught divided by R. Now look, in this both the current and the EMF, they are in the same phase. So how will we draw it on the phasors? Look here like this. This blue one is EMF, this red one is I current. So both are overlapping each other, means there is no phase difference between them. There is no angle, both are rotating with the same speed. This length can be determined by the magnitude. Now look, EMF's graph, you can see both have the same starting point, both have the same ending point. This gap that is coming, this is because of magnitude. If magnitude of current becomes greater, it will rise more. But there is no angle difference between them. So phase means angle, there is no angle difference. This is how we write it. This is the entire theory about the circuit having only resistor. This is clear? Write it down. Any doubts you have, let me know. Okay.